at radioactive particles. Radioactive particles. And what are radioactive particles? The radioactive particles are those particles that are emitted or produced during radioactivity. They are those particles that make that atom or the nucleus of the atom unstable. As soon as these particles are emitted, the stability returns to the nucleus of the atom. Now, what are these particles that can be emitted during radioactivity? The first one there is the one we call the alpha particle. The second one there is the one we call the beta particle. And the third one is, we will have the gamma ray and the X-ray. The fourth one, we have the positron. We have also, we have the neutron. A neutron can be emitted during radioactivity. Even a proton can also be emitted. X-ray is not excluded, it's also among. So these are some of the particles we'll be looking at that are emitted during radioactivity. Now, what we are going to study in this case is when a particular particle is emitted, when an element emits alpha particle, for instance, what becomes of the element? Remember, when you are unstable and you finally give out that thing that makes you unstable, you will not remain the same. There will be a change in you. And what is the nature of the change? The nature of the change, what you will become, depends on what you give out. If you have a sinner as a friend, and you decide to sacrifice this your friend, you are tending to become a saint. That's just it. You will not remain the same. So when any particle is emitted, there must be an observable change in the element that emitted it. If you emit alpha particle, what becomes of you? If you emit beta particle, what becomes of you? If you emit gamma ray or X-ray, what becomes of you? And if you emit positron, what becomes of you? If you emit neutron, what becomes of you? So there must be a change when any of these is emitted from you. How do we know what you will become? Remember, what happens to you when you emit an alpha particle is different from what happens to you when you emit a beta particle. It's also different from what will happen when you emit a neutron. There are different things that will happen to you when any of this is given out from you. Now, the symbol for alpha particle is the alpha sign or the helium atom. We can use helium to represent alpha particle. Why? Because alpha particle from observation shows that it has the same mass with helium atom. So the symbol for alpha particle is alpha. The symbol for beta particle is the beta sign, or you use the sign of electron, E. Why do we use electron sign? Because it has the same characteristics with the electron. So beta particle simply means electron. The symbol for gamma ray is the gamma sign. And the symbol for positron is still the beta sign, but in opposite charge. Beta is positive. Sorry, positron is positive, while beta is negative. The neutron has a symbol of the neutron, you know, which is N. The symbol of neutron is N. Now we are going to look at the values attached to each of these particles, and then what happens to the element that gives out any of them. Remember, the alpha particle has mass of 2, atomic number of 2, The alpha particle has atomic number of 2, atomic mass of 4. The beta particle has 0 here for atomic mass, -1 here for atomic number. Gamma has 0, 0, both mass and atomic number. Positron has 0 and +1. Positron is just opposite of beta. And neutron has 0 and 1. 0 and 1. Now, in the next video, we are going to take each of them. Let's see, when an element gives out alpha particle, what happens to the element? When an element gives out beta particle, what happens to the element? And so on and so forth. That will be in the next video. Thank you for watching, and do not forget to share with your friends and your classmates. Invite them to learn in this channel. Thank you.